Hi friends, this is Sujivna, belongs to CSCA section of Adi Shankara Institute of Technology. Today I am here in front of you to explain my tech talk on minimum cost spanning trees and its algorithms, which comes in the subject of design analysis and of algorithms. Here, first of all, what is a spanning tree? Here, the spanning tree can be defined as the subgraph of an undirected connected graph. It includes all the vertices along with at least possible number of edges. A spanning tree is a subset of the graph that does not have cycles and it also cannot be disconnected. A spanning tree consists of n-1 edges where n is the number of vertices. Edges of spanning tree may or may not have weights assigned to them. All spanning trees created have same number of vertices, but the number of edges in the spanning tree would be equal to the number of vertices minus 1. A complete undirected graph can have n power n minus 2 number of spanning trees where n is the number of vertices. Applications of spanning tree. Here we have some applications of spanning tree. Basically, a spanning tree is used to find a minimum path to connect all nodes of a graph. Some of the common applications of the spanning tree are listed below. They are cluster analysis, civil network planning, computer network routing protocol. Here, example of spanning tree. Here we have an undirected connected graph. Undirected in the sense there is no specific mentioning of the direction, whether the vertex or edge from C to A or A to C or B to C, like that. There is no specific direction, so it is undirected, but those three are connected to each other, so this graph is called as connected undirected graph. So as we have three spanning trees of this graph. They are the following graphs. As we discussed above, n is number of vertices. So if the graph has three edges, then the spanning tree also has three edges. If the graph has three edges, then the vertices of spanning tree will be 3 minus 1, that is 2. So we have three vertices, three edges all over the three spanning trees, but the vertices are only 2. So this satisfies our conditions. So these are called spanning trees. Properties of spanning trees. There can be more than one spanning tree of a connected graph G. A spanning tree does not contain any cycles or loops. A spanning tree is minimally connected. So removing of one edge from the tree will make the tree disconnected. A spanning tree is maximum acyclic. So adding one edge to the tree may create a loop. I will explain with an example. The second point is a spanning tree does not contain any cycles. We can see here there are no self loops or cycles. Cycle in the sense it should be a closed path. This is called cycle, but these are not cycles. So second one is verified. Now a spanning tree is minimally connected. A spanning tree is constructed with minimum number of vertices. So if we remove any one vertex, it becomes disconnected. So we should not remove any vertices. A spanning tree is maximum acyclic, so adding one edge. So here adding one edge may create a loop. So we should not add or remove the edges to the spanning tree. Minimum cost spanning tree. A minimum cost spanning tree is defined as a spanning tree in which sum of the weights of the edge is minimum. The weight of the spanning tree is the sum of the weights given to the edges of the spanning tree. In the real world, this weight can be considered as the distance, traffic load, congestion, or any random value. Here are the examples of spanning tree. I have taken the same example, but here we have assigned some weights to the spanning tree 1, 8 and 2. We have three spanning trees present over here, but For becoming minimum cost spanning tree, the weight of the whole spanning tree must be minimum. So we have total 9 here, total 10 here and total 3 here. So this will be the minimum cost spanning tree. Applications of minimum cost spanning tree. The applications of minimum cost spanning tree are: minimum cost spanning tree can be used to design water supply networks, telecommunication networks and electrical grids. It can be used to find paths in the map. Algorithms for minimum cost spanning tree. A minimum cost spanning tree can be found from the weighted graph by using algorithms given below. They are Prim's algorithm and Kruskal's algorithm. Prim's algorithm is a greedy algorithm that is used to find the minimum cost spanning tree from a graph. Prim's algorithm finds the subsets of edges that includes every vertex of the graph such that the sum of the weights of the edges can be minimized. Prim's algorithm starts with a single node and explores all the adjacent nodes with all the connecting edges at every step. The edges with the minimum weights causing no cycles in the graph got selected. Next, how does Prim's algorithm works? Prim's algorithm is a greedy algorithm that starts from one vertex and continue to add the edges with the smallest weight until the goal is reached. The steps to implement the Prim's algorithm are given below. First, we have to initialize a minimum cost spanning tree with the randomly chosen vertex. Now we have to find all the edges that connect the tree in the above step with the new vertices. From the edges found, select the minimum edge and add it to the tree. Repeat step 2 until the minimum cost spanning tree is formed. So, to understand it more better, I came with an example. So, this is the minimum. Sorry. Sorry for the inconvenience, friends. So let me take a pen. So here we have a spanning tree. We should find the minimum cost spanning tree of this tree so that the cost of the tree must be very low. Now let's see the working of Prim's algorithm using an example. It will be easier to understand the Prim's algorithm using an example. Suppose a weighted graph is taken. This is a weighted graph. We have to draw a spanning tree with the minimum cost. So the step 1 is, first we have to choose a vertex from the above graph. There is no specific vertex. We can select any vertex. So I have selected B. So first draw B here. After that, step 2. Now we have to choose and add the shortest edge from the vertex B. There are 2 edges from vertex B. There are 2 edges from the vertex B. They are 4 and 10. So we have to choose the minimum edge, the minimum distance. So we will be choosing 4. Then the connection from B comes to D. So here we can see the connection from B to D. Next we have 2 options present over here. We can draw connection from here or here, but we have to choose with minimum cost. So let's go to the third step. Now again choose the edge with the minimum weight among all the other edges. In this case, let me go to the tree. Yeah. Here from D we have 3 opportunities, 4, 2 and 1. From B we have 4 and 10. But as we see, the minimum one is from D to E. So we will be drawing D to E here. Now step 4. Now select the edge CD and add it to the MST. Why we have selected CD? Because after 1 the minimum cost is from D to C. So we have selected CD here and we have drawn. Now step 5. Now choose the edge CA. Why we have selected CA? Because after 1, 2 we have the minimum cost with CA connection. So we have drawn that see a connection here. So the cost of minimum spanning tree is 4 plus 2 plus 1 plus 3 is equal to 10 units. So we may have a doubt. How does we know that the spanning tree of ours is completed? So to know that, we have to check first how many vertices are present in the tree and how many vertices are having in our spanning tree. So let's check with our spanning tree. We have A, B, C, D, E, 5, and from tree we have A, B, C, D, E. So our spanning tree is finished because the vertices are 5 and our spanning tree also has 5. So the minimum cost of spanning tree is 10 units. So this is the example of Prim's algorithm. Hope you have understood. Now the next one is Kruskal's algorithm. Kruskal's algorithm is used to find the minimum spanning tree for a connected weighted graph. The main target of the algorithm is to find the subset of edges by using which we can traverse every vertex of the graph. It follows the greedy approach that finds an optimum solution at every stage instead of focusing on the global optimum. How does Kruskal's algorithm work? In Kruskal's algorithm, we start from edges with the lowest weight and keep adding the edges until the goal is reached. The steps of implementing Kruskal's algorithm are listed as follows. First, sort all the edges from low weight to high. Now take the edge with the lowest weight and add it to the spanning tree. If the edge to be added creates a cycle, then reject the edge. Continue to add the edges until we reach all vertices and a minimum cost spanning tree is created. To understand it better, I have come with an example. Now let's see the working of Kruskal's algorithm using an example. It will be easier to understand Kruskal's algorithm using an example. So I have a undirected connected graph here. So as stated above, we have to segregate the weights of the edges from minimum to maximum. So first we have taken AB, AC, AD, AE, BC, CD and E. We have selected all the connections and we have also noted all the weights here. Now sort the edges given above in the ascending order, and I have done it. Here. We have an ascending order. So the first connection is 1, 2, 3. So these are arranged in ascending order. Now let's start constructing minimum spanning tree. Step 1. First, add the edge AB with weight 1 to the minimum cost spanning tree. As they are above stated, we have to have the minimum weight. So we have to select the minimum one. So here we have AB which is having minimum distance of 1. So we have taken the connection AB here. Now step 2, add the edge DE. After AB we have DE with 2 units of distance. So we will be having DE present over here. The difference between the Prim's algorithm and Kruskal's algorithm is Prim's algorithm from starting to ending it will be a connected spanning tree, but here Kruskal's algorithm in the starting or middle it may not be connected, it may be disconnected, but at last as we are getting spanning tree that will be a connected spanning tree. No worries about that. Yeah. From step 3, add the BC with weight 3 to the minimum cost spanning tree as it is not creating any loop or cycle. First we have drawn AB and from AB to we came to ED. After 1, 2 we have 3 here BC. As it is not creating any cycle, we can draw it. So from B to C it had a connection. Now step 4. Now pick the edge CD with the weight 4 to the minimum cost spanning tree. It is also not connecting or not creating any cycle, so it can be connected. Now step 5. After that pick the edge AE. pick the edge AE with weight 5. Including this edge will create the cycle. So discard it. AE. Where is AE? Yeah. Here we have AE. Sorry friends, sorry for the inconvenience. Step 5. After that, pick the edge AE with weight 5. Including this edge will create the cycle. Similarly, AC and AD also creates cycles. So we will be discarding these three edges. So the cost of the minimum spanning tree is 1 plus 2 plus 3 plus 4 is equal to 10. 10 units is the cost of minimum spanning tree. Thank you guys. Hope you have understood. Thank you.